Okay, I want to make sure I clear up any confusion you might have regarding number 30 on your practice exam. And let me make sure I'm sharing my screen with you. Okay, so I am sharing my screen and let's go into that. Okay, so for this problem, what um, what makes this easier is if you just instead of working off of this initial problem is to just simply rotate the problem, um, rotate it about 45 degrees uh, to the left, and so it looks a little bit more in standard form. And so what I did was I resolved the two vectors that were not in line with my standard XY axis, things that you're gonna have to do for the test. And if you notice over here, this is my positive x-axis, which I just put over here. So here's my x plus over here, and up here is my y plus. And then I resolve the two vectors. The two vectors that I need to resolve are this F2 vector, which is 6 newtons, 28 degrees off from the positive side of the x-axis, and uh, the second vector over here, which is 5 newtons off the negative side of the negative side of the x-axis. And so I resolved them F1 here and here. You can see them in red. And I resolved F2. I'll put that in, I think I did that in a black color. So it's here and here. So those are the four vectors that you're going to need to calculate. And what was a little odd about this problem, because I grabbed it right before class, is that this is not typically how I write problems. So, but we can still solve them. So just look at the motion in the x direction. So let's get my pen to work. And so if you look at all the forces that are in the x direction, you have this force right here, which is positive, and you have this F1x, which is negative. And so just sum those up. And the value of those, there's your x, and then there's your other x, turned out to be equal to this numeric value. And the same thing for the y. The two y values I added together were here. That's the y component for your F1, and then here or here. And so remember, the acceleration vector has its own x and y components as well. So even though it's a very small number, that number there and that number there represent the x and y acceleration components for the acceleration vector itself. And then it just looks like. And so if you're really interested, I usually don't give problems like this on the test that have this type of format. So if you're interested in trying to get those a little cleaned up, this would be your x component for your second vector. I called it, let's see, the 6. So that's the F2. And then here's your x component for your um, F1. And then you have to kind of know some trig identities here. Cosine of 128 degrees is the same as the negative of 5 times the cosine of 22 degrees. So they get a little tricky on you up here. And the answer was C for this particular case. And so you'll see that if you look at my math here, you look at all this math here and look at the x and y components, add them up, you should be able to solve this problem. So hopefully this gives you some clues as to what you're going to need to do on test number 1. But typically I don't set my problems up this way. You'll see them as you saw in class, where you're going to need to resolve those vectors, especially when they're on an incline such as this. All right. Hope that helps. Take care.